Welcome back to another quick Python tutorial. Today we're going to put everything we've done so far and put it all together into one problem. We are going to design logic for a problem and code the problem in Python. So we're going to do this in three parts in this one video. We're going to design pseudocode, a flowchart, and a Python program all wrapped around this problem right here. We're going to design the logic for a program that will allow the user to enter an integer starting seconds value, convert that into hours, minutes, and seconds. And then essentially we will display all the information that we need in order to get this to happen appropriately. So let's get into the pseudocode. What I like to do with my pseudocode and my flowcharts is always have some sort of beginning and end to my logic. That could be a module name and some sort of return statement, or a function name and a return statement, but in this case right now we're just writing a quick script that's just going to be a single program all the way through. So what I'm going to begin with is either begin main or end main, or I am going to just simply say start and stop. Okay, that is how I'm going to begin my program, and I'm going to put everything in between those two brackets so that I know my program starts here and it stops here and it's all said and done. Now, I always like to make some sort of indentation. That indentation doesn't have to be very large, but there's an indentation here to say, hey, I'm actually within this block of code. This block of code is going to contain your mainline process and any declarations you have, your input, process, and output, and your declaration. So here, I'm going to start with my declarations because I need to come up with namespace and memory and understand what the data types that I'm going to be working with are to help me with the operations that I'm going to use later. So I'm going to go declarations. And in those declarations, I'm going to describe what my variables are going to be, not necessarily give them value yet, but describe what they're going to be, what they're going to be called, and what data type they're going to be. So I am going to have an integer value for the starting seconds. All right. I'm going to have an integer value for the number of hours that it converts into, an integer value for the number of minutes that it converts into, and an integer value for the number of seconds that we have left over, okay? And I don't want starting seconds, I just want seconds, okay? All right, so now I'm gonna back out of that because I'm no longer making declarations, and I'd like to go through my process where I do my input, followed by my processing, followed by my output. I always like to have these three phases in my program. So first thing we're going to do is gather input. So let's stay inside here. And what we need to do is just input the starting seconds. Remember, this is pseudocode. It's not real code. So we're not going to write Python, we're not going to write C, we're not going to write Java or anything like that. We're going to write simple, basic commands that are easy to understand and apply in any language that I want. I don't need to write the prompt or anything like that. I just need to say what I'm doing. I'm going to input the number of starting seconds, and that's it. And that is the only thing in this entire program that we are going to input. So now it's time to move on to the processing. Now I'd like to process the number of hours, minutes, and seconds that are in those starting seconds. And we have to do a little bit of thinking and some arithmetic to make that happen. So here's what I know. I know that there are 60 seconds in a minute and there are 60 minutes in an hour, which essentially means there are 3,600 seconds in an hour. So I can start to do some math and figure out how many hours there are in those starting seconds. So I'm going to go with hours equals, or I'm going to say set hours equal to, and I'm going to do the math. Now I know this could be code, absolutely could be code in some languages like in Python, but it doesn't have to be. It can be just something simple like you say it or whatever it is, but you got to get the driving idea across that you are going to be doing some math. And in here, if I want to figure out the hours, I'm going to take the starting seconds and I am going to divide it by, okay, 3,600, because that is exactly how many seconds there are in an hour. Now, if you want to get more specific towards Python, remember you can use that double slash to help you out, but really it doesn't make a difference whether in your pseudocode you decide you're going to use a double slash or single slash. You just need to indicate that there's division going on. If it was modulus, I'd say use the remainder symbol, the % sign. But for division, you can use 1 or 2 in your pseudocode or flowchart and still get the idea across. Now I'm going to use the double slash just to make things easier on myself later. But I know the starting seconds is an integer. I know hours is going to be an integer, so I should get an integer value in some way, shape, or form. Now that I've got the hours taken out of those starting seconds, I'd like to see how many seconds are left to help me calculate the minutes. So what I'm going to go set seconds equal to the starting seconds, and I'm going to divide it again by 3600, but notice the different type of division. I'm going to use the remainder. I want to see how many seconds are left after I've already done the 3600 seconds per hour. That'll give me less than 3600 seconds, a value much less than that, hopefully, and it'll be something that I can apply into minutes. Okay. So here we're going to set minutes equal to my seconds, not the starting seconds anymore, but the seconds that are left over from taking out the hours, and we're going to divide that by 60, and I can set seconds equal to the seconds mod 60, and that will allow me to see how many seconds are left over after I've taken out all the minutes. At this point, I've got all of my calculations done, so I can start displaying a few things. I want to display the starting seconds. Okay. I want to display the hours. I want to display the minutes. And I want to display the seconds. That way it gives me a nice display where it says the number of starting seconds there are, plus the number of hours, minutes, and seconds that it equates to. So again, just to recap the process, okay? This is simply being held here because we would like to show that there are 3,600 seconds in a single hour. And that'll help us decide how many hours there are in our starting seconds. This particular line of code, if we're thinking about this, helps me determine how many seconds are left after hours have been removed. Okay. And the same basic idea here. This is going to help us determine how many minutes there are. Okay. So how many minutes there are in the remaining seconds. And this very last thing is going to be how many seconds are left after minutes have been removed. Okay, and that does it for our logic on this particular problem. We're going to flip over and do the flowchart for this problem next. Alright, so in part 2 of this video, we want to talk about how we can take our problem and put it in a flowchart form. So I'm going to go to draw.io to create my flowchart. This is just a quick flowchart maker that we can use to help build whatever we want. When you get here, you're probably going to be faced with a dialog box like this where you can save it to different places. Go ahead and save it to wherever you want. I'm just going to simply choose device for now, and I'm going to create a new diagram. Now for me, I'm going to want to create some sort of flowchart, but in the flowchart tab you get all sorts of crazy options. We don't need anything all that complicated, so we're just going to go with basic and choose a blank diagram. Okay. Here I'll have to give it some sort of name. We're going to call it our time conversion. Save. And here we go. So this is draw.io and its interface. What you're going to notice here on the left are all the tools that you can use, and on the right there are some styling points that you can put in here. Now I'm actually going to collapse the general tab and open up the flowchart tab because it has all the symbols we need. The symbols we basically need are our terminator symbols. Those are our start stops or our module headings and the return statements. We're also going to need a rectangle, which is our process. We will use that for all the processing parts, plus all of our declarations. We are going to need, in this particular one, also the data symbol. This is going to be our input and output symbol. The other symbol that we will use most often in this class is a diamond, which will represent our decision symbol. This is when we'll get into conditional logic, if-then statements, and looping structures. So let me do us a favor. We'll zoom in here a little bit so it's a little bit bigger. And I am going to start with the, oops, let's see if we can find our logic, where'd it go? It's over here. Perfect. Okay, we're going to start again with the problem. Remember, our problem was to design the logic to convert some time. We had our declarations, our input, starting seconds, hours, minutes, seconds, so on and so forth. So I'm going to bring in my terminal symbol, just kind of line it up in the center, and as soon as I'm in it and I have it selected, I can actually type in it. Just start typing start. Okay. These handles here allow you to resize anything that you want. Okay. And now you just start bringing stuff in. So the next part of my logic was my declarations. My declarations are going to be held in a processing symbol. So I'm going to grab and drag in a process. Now as I drag it in, you're going to notice little guidelines kind of pop up to kind of help you align some certain things. I like to keep things very centered on my process. So I'm going to type in declarations here and hit enter, and I'm going to say integer starting seconds. I'm going to say integer hours, integer minutes, integer seconds. Now something I didn't mention in the last part is that I start all of my variable names with lowercase letters. It's going to be important that you do that as well so that we can give the right same naming conventions. So again, I resized it, centered it up. It's nice to have everything nice and centered. Now to connect a flow line from one place to another, all you have to do is deselect anything, hover over any object, and you will see handles pop up that highlight in green. And you can click and drag to those other handles on other objects. And now you've connected a flow line to it. No matter how you drag this around, it will stay connected. Now again, I like to keep them very straight and centered, and I'm going to expect that you do the same. Keep everything straight down the middle. So now that we have our declarations made, we can start making our input. So I'm going to grab in a data symbol, which is our input-output symbol, a parallelogram. I'm simply going to write input starting seconds. And again, I'm going to stretch this out so that it fits in there a little nicer, line it up, and then I'm going to deselect, go to find my handle, click and drag to another handle, and there you go, you have your starting seconds. Now to move on to the processing, okay, you're going to notice we're going to do 4 different processes, okay? So essentially I'm going to bring in 4 different rectangles. Now you can combine some of these processes into more than one rectangle. I'll show you how we can do that, but I like to keep them pretty separate for the most part as long as they're not talking about related data. So here I'm going to say something like set, I'm going to go hours equals starting seconds divided by 3600, okay? And there's one piece. And again, I can connect those two. Hover, find your handle, click, drag to the next handle. And now if you find yourself that you're using the same symbol more and more often in draw.io, you get this nice little arrow here that will allow you to copy the symbol and its contents along with already connecting a flow line. And so, it looks like they've updated it. So I can put in a process symbol and it won't copy the contents, which is nice. And now I can just start typing. So that's actually going to make things much more helpful. So now I can set seconds equal to starting seconds mod 3600. And there it is, and it's nicely connected. Now let's go ahead and use that tool again where we get the arrow button. And I'm going to bring in a process symbol, and they're already connected with a nice flow line. And I'm going to set minutes equal to seconds divided by 60. And again, let's just drag that out, make it nice and neat. Get our arrows nicely aligned, okay? Make that a little skinnier. And I'm going to hit that down arrow again and get one more process symbol out here, drag it up, and I'm simply going to say seconds or set seconds equal to seconds mod 60. Now it doesn't matter whether or not you use the word set or calculate or find. All of those things still mean the same thing, whether in your flowchart or in your pseudocode. You just have to make sure that you use some sort of verb there to say that we're doing some sort of process. All right, our process is over. Now it's time to get into the display. And so for now, I'm going to bring in a data symbol for my output. Input and output share the same symbol, and I'm simply going to say display or print my starting seconds. And we'll drag that out so it's a little bigger and a little narrower, and we'll connect them because I forgot to just click and I dragged in. So let's click on that arrow coming down. We'll pick a process symbol. And in that case, it duplicated it for me, size and everything, which is kind of neat. We'll say display hours. Okay. We will click and drag another one, and we'll hit that again, and we will display minutes, And let's just clean that up a little bit, bring them back up where they're a little bit closer and still in line. Keeping everything in line is very important. You should only move left or right if you're using a decision. So nowhere in this week or in this lab should we do any branching left or right or have any arrows moving left or right. Display seconds. And then finally, we are going to terminate this. So let's see if that symbol is in here. Do we have a terminal symbol? We do have a nice oval here. Now, you can use that if you started with an oval up at the top, and I'm okay with that. But I'm going to be neat about this and bring in my terminator symbol. And I'm going to say stop. And I will go ahead and make that a little smaller. And we will connect everything with a nice neat flow line. And we'll zoom out so that we can see everything together. You can see that everything's nice and tight. We can move some things around just to make sure it's viewed well, okay? And then last but not least, being able to display this so that it can be turned in. In draw.io, you have lots of options here for exporting information. You can export things as images or PDFs. I often like using a PDF because it's easy to put it and upload it into anything you need. Now you can do the whole frame, or you can simply select everything in the frame if you wish and just have a PDF of the certain selection. Again, it doesn't make a difference. Here I'm just going to export as PDF, and I'm going to get everything. And go ahead, if you want a transparent background, pick a transparent background. Doesn't make a difference, but you are going to include everything. And I'm just going to go to my device because it's easiest. It will download, and you can see that if I click on it, it's going to give me a document that has everything I need. If it ends up on multiple pages, it ends up on multiple pages. That is not a problem for me. You can always look at it and make sure that all your modules are exactly the way that you want, but that's the basics of a flowchart. You have right now 3 symbols that you need to work with, 3 basic symbols you need to work with. The input-output symbol. Okay, parallelograms. You have your rectangle for your processes and your declarations, and you have your terminal symbols, which are your ovals. We will introduce some more symbols as we start to grow in our logic, but for now, that is what we have. And so in the next part, we're going to take this flowchart and our pseudocode, and we're going to turn it into Python. So stick around for that. All right, let's get into part 3 of this video where we actually code out our solution in Python. So if you remember, we have made our declarations, we've got input coming in, our processes, and our output. Now the thing is, with Python, we are not actually going to do the declarations. Every variable that we make in Python is grabbed the moment we give it value. So we're just going to kind of start coding with the input part of this, and we're going to say starting seconds equals, okay, and we need the integer version of our input, and we'll put in our prompt here. And so here I might say something like enter a number of starting seconds. And I'll make it look real pretty with a nice little colon and an extra space there. And so there I've got the starting seconds coming in, and I've got it coming in as an integer. So now I'm going to go ahead and calculate the hours is equal to my starting seconds divided by 3600. Okay. I'm using the double slash again because I want to make sure that this is floor division. I get an integer value out, no decimals. It doesn't make any sense to have a decimal answer for hours. Not even a 2.0, it doesn't make sense. It's just a straight 2. All right, so then we're going to go with seconds equals my starting seconds. And we're going to go with mod 3600 to get the number of seconds left over after I've already taken out all the hours. Okay. I'm going to get into the next part of the process, and I'm going to go with minutes equals my seconds, because I want to use how many seconds are left over, not the starting seconds, because I've already processed that with hours. And I want to divide that by 60. And then I want to go seconds equals seconds mod 60. And then I can make up my displays, and these are the print statements. So I'm going to go with a print, and we'll type out something like this. We'll go starting seconds, and we'll throw in a colon, and we'll do that, and we'll go with a dot format, and we'll put in starting seconds. I can spell it. Okay. And essentially we're going to do the same thing 4 times over. So print hours. Minutes. And there we go. And so we can go ahead and save this, run it, and here we go. We can enter in a certain number of starting seconds. Let's say we entered in like something easy, 143 starting seconds, just to see what it is. There are no hours in 143 seconds, but there are 2 minutes. There's 120 seconds in 2 minutes and 23 seconds, so we know it's working there. And we can run it again if I come over here at F5 and I type in something a little bit larger. Let's say we do something like 6,000 seconds. That's 1 hour, 40 minutes, 0 seconds. And you can crunch the numbers, you can see that it all worked. The only other thing that I might want to do when I come over here is it's always a good idea to comment your code. Python comments always start with a hashtag, and then you can kind of write in the same comments we did in our pseudocode. So this calculates, finds hours from starting seconds. This finds how many seconds are left. Okay. And your comments aren't supposed to be like a reincarnation of your code, but they're meant to describe your code. So this finds the minutes from remaining. Okay. So those are just some programming comments that allow us to kind of see what the program's doing. You notice they don't actually get executed at all. I can save this, run it, nothing happens any different than what we had before. And now I can tell how many hours, minutes, and seconds. And if I wanted to take this program out and do days and weeks and years, I absolutely could. But this is all I'm asking for at this point in time. You notice we only use division in this particular lab, but your other operations will work basically the same way. So there you go. That kind of takes us from pseudocode, okay, what we have here, starting with that. We devised our problem. We broke it up into our IPO process, input, processing, and output. We designed the same thing in a flowchart form. You can see input, processing, and output. You should be able to see it in your flowchart. And again, your flowchart should have a nice center line to it. Shouldn't break right or left unless we're making some sort of decision, which we're not. And you can see that my program has that nice kind of flow to it. Everything's left justified. Everything works out. Here's my input. Here's my processing. And finally, my output. And we should follow that way. So hopefully that kind of helps get the ball rolling on the next few activities that we're going to be doing and kind of gets you in the groove for how to do some basic pseudocode flowcharts and again, write your scripts. So keep that in mind as you're working on projects for me, moving on through. And if you have questions, feel free to ask.